Hello everyone. In this AV, we are going to solve the numericals of the third chapter, that is laws of motion, and in particular the gravitation portion. The first numerical says, a force of attraction between the two bodies at a certain separation is 10 Newton. What will be the force of attraction between them if the separation is reduced to half? Now in this numerical, we will be using the universal law of gravitation. So first we write the given things and then the equation for the universal gravitational law. So we have written the given things, that is the force of attraction, and we assume it to be F1 is equal to 10 Newton, and we know from the universal law of gravitation that F is equal to gmm upon r square, where F is the force of attraction between two bodies. Capital M and small m are the masses of the two bodies, and r is the distance of separation, and capital G is the universal gravitational constant. So we have written where the symbols have their usual meaning. So this is given to be equal to 10 Newton. So instead of F1, we write 10 is equal to gmm upon r square. So when the distance of separation is reduced to half, then this r will become r by 2. So we have written that when the distance of separation is reduced to half, then r is equal to r by 2. So we rewrite this equation, that is universal gravitational law, in terms of F2, because now the r is reducing to r by 2. So we have the equation as F2 is equal to gmm upon r becomes r by 2 square. So when we square it, we get r square by 4. The 4 goes up in the numerator. So we have 4 gmm upon r square. Now gmm upon r square is nothing but F1, which is equal to be 10 given in the question. So instead of this, we will substitute 10. So F2 is equal to 4 into, instead of gmm upon r square, we have written F1. The value of F1 is 10, so we get 40 Newton as the answer. The third question says, calculate the weight of the body of mass 10 kg in number 1 kgf and number 2 in newtons. Take the acceleration due to gravity, that is g, to be equal to 9.8 meter per second. Here we know the relation that 1 kgf is equal to 9.8 Newton. So we'll be writing the given things and then using that relation. So the mass given is 10 kg. So weight in kgf will be 10 into 1 kgf, that is 10 kgf. We know that 1 kgf is equal to 9.8 Newton. So therefore the weight in Newton is equal to mass multiplied by 9.8 Newton. Mass is 10 kg multiplied by 9.8 Newton. So we get 98 Newton as the answer. Question 5 says, the weight of a body is 2 Newton. What is the mass of the body? Given that acceleration due to gravity g is equal to 10 meter per second square. So it's given that the weight of the body, that is W, equal to 2.0 Newton or 2 Newton, and acceleration due to gravity is equal to 10 meter per second square. We know the relation weight is equal to mass multiplied by acceleration due to gravity. So we have weight given to us and acceleration due to gravity given to us. So from that equation we can find out the mass. So we have written that weight is given as product of mass and acceleration due to gravity. From there we get that mass is equal to weight upon acceleration due to gravity. So weight is given as 2 Newton and acceleration due to gravity is 10 meter per second square. So we get it as 2 upon 10, which is nothing but 0.2 kg. So our answer is mass m is equal to 0.2 kg. Question number 6 says, the weight of a body on earth is 98 Newton, where the acceleration due to gravity is 9.8 meter per second square. what will be its mass and weight on moon where the acceleration due to gravity is 1.6 meter per second square. So first of all we write the given things. So here we have written that weight of the body on earth and we are representing it with WE is equal to 98 Newton and acceleration due to gravity G is equal to 9.8 meter per second square. Again we will use the relation weight is equal to mass multiplied by acceleration due to gravity, or W equal to mg. So we have W equal to mg. From here the mass of the object or mass of the body can be found out, and that mass can be multiplied by 1.6, that is the acceleration due to gravity on moon, and we can find the weight of the body on moon. So here m is equal to W upon g. The value of W is 98 Newton divided by acceleration due to gravity is 9.8. So when we divide it after calculation we will get 10 kg. So therefore mass m is equal to 10 kg. So we have found out the mass of the body, and this mass when multiplied by the acceleration due to gravity on moon will give us the weight of the body on moon. So we write let Wm be the weight of the object on the moon, and we have been provided with the acceleration due to gravity on moon, that is 1.6. Again we will be using the equation weight is equal to mass into acceleration due to gravity. So since we are talking about weight on moon, so acceleration due to gravity will be taken to be on the moon, that is 1.6 meter per second square. So we know weight on moon will be equal to mass multiplied by acceleration due to gravity on moon. Mass of the body remains constant. Only thing that changes is the weight, and it changes because of this factor, that is the acceleration due to gravity. So we put the values, and the values are mass of the body we have already calculated here, 10 multiplied by acceleration due to gravity 1.6. So this comes to be 16 Newton. So now weight of the object or weight of the body on moon is 16 Newton. Now question number 9 says a ball is released from a height and it reaches the ground in 3 seconds. If g or acceleration due to gravity is 9.8 meter per second square, we have to find the height from which the ball was released and the velocity with which the ball will strike the ground. Here we will be using those equations of motion, the 3 equations of motion, the derivation of which you have done in this chapter itself. So first we write the given things. So we have written the given things, that is time taken is given as 3 seconds, acceleration due to gravity is 9.8, we have to find the height. So we will be using the equation s equal to ut plus half at square. Here s, which is the distance covered, will be our height. So the equation s equal to ut plus half at square has been modified, and in place of s we are writing h, that is the height. Ut remains the same. Instead of a, that is acceleration, we are here in this case we are writing g, that is the acceleration due to gravity. Now as the initial velocity is 0, so this whole term becomes 0. So h is equal to 0 plus half 9.8 multiplied by 3 square. Since initial velocity, that is u, was 0, this whole term 0 multiplied by t is 0. So when we calculate we get h is equal to half 9.8 multiplied by 9. When we multiply we find it to be equal to 82.2 upon 2. This will be 44.1 meter. So the height is 44.1 meter. Now the second part of the question, we have to find the final velocity, that is v, with which the ball will strike the ground. So here we will be using the equation v equal to u plus at, because all the values are known to us, and using those values the final velocity v can be calculated. So we write v equal to u plus at. Initial velocity u was 0 plus acceleration becomes acceleration due to gravity, so we write it as 9.8 multiplied by time taken, which is 3 seconds. So when we multiply, we find it to be equal to, the velocity will be 29.4 meter per second. This is the answer. Now the next question says, that is question number 11, says a ball is thrown vertically upwards. It goes to a height 20 meter and then returns to the ground. Taking acceleration due to gravity, that is g, to be 10 meter per second square, find the initial velocity of the ball, the final velocity of the ball on reaching the ground, and the total time of journey of the ball. So here we will be using those equations of motion. So first we write the given things. So we have written what is given to us, that is maximum height. Here in this case we are taking it to be s, that is the distance traveled, equal to 20 meter, and acceleration due to gravity is 10 meter per second square. Here we have to understand that in the question it says that a ball is thrown vertically upwards. So in this scenario, when the ball reaches its highest point, before it returns back, the velocity will be 0. It will stop for some time. So here in this case, we will assume that u is the initial velocity with which the ball is thrown upwards, and once it reaches the highest point, the velocity becomes 0. So u is the initial velocity and v, that is the final velocity, will be 0. Final velocity will be 0 and u we have to calculate. So we use the equation v square minus u square is 2as. In our case, instead of a we will be writing g, that is acceleration due to gravity. So when the ball is thrown up, initial velocity was u, and when it reaches the highest point, that is its final velocity will be 0. So we write 0 minus u square is 2. Acceleration due to gravity, that is g, is given to be 10 multiplied by the distance, which is equal to be 20. So we get here minus u square is equal to 400, or the minus can be taken that side, so it becomes u square is equal to minus 400. Please remember that the negative sign indicates the motion is against the gravity. And when we find the square root, so u will be equal to 20 meter per second. That is the answer for the first part. Now for the second part of the question number 11, we assume that v is the final velocity of the ball when it reaches the ground. Now we will be considering the motion from the highest point to the ground. So when we consider the motion from the highest point to the ground, at the highest point the velocity was 0. So in this case our initial velocity at the highest point will be 0, and we will be calculating the final velocity. So we write the given things. So here we have written the given things. Also the distance s is given to be equal to 20 meters. Now we will be using the equation v square minus u square is equal to 2gs. Now we put the values. After putting the values, we have v square minus initial velocity is 0, which was at the highest point, velocity was 0 because the ball stops, is equal to 2 multiplied by 10, that is the acceleration due to gravity, multiplied by the distance traveled, that is s, equal to 20. After multiplying, we find it to be equal to 400. When we take the root, we find that the final velocity v comes out to be equal to 20 meter per second, which is the answer. Now the third part of the equation. For the third part, we have to find out the total time for which the ball remains in the air. So we will be using the equation t equal to u upon g, but here the total time will be twice. Once for the ball or the body to go up, and then when it comes down. So we will simply find u upon g and multiply it by 2. So the total time for which the ball remains in air, time is equal to 2u upon g. So we will write the values. 2 is as it is. Initial velocity u, we have calculated it to be 20 upon the acceleration due to gravity, that is 10. After calculation, we find it to be 4 seconds. So the time for which the body or the ball remains in the air is 4 seconds, which is the answer. Question number 12 says, a body is dropped from the top of a tower. It acquires a velocity 20 meter per second on reaching the ground. Calculate the height of the tower. Take acceleration due to gravity, that is g, to be equal to 10 meter per second square. Now in this question, to find out the height, which we will be finding out in terms of the distance traveled, we have to first calculate the time that it takes for reaching or covering that height. So first we write the given things, and then using the equation v equal to u plus at, we calculate the time. So as the ball is dropped from the top of a tower, so initial velocity u is 0, final velocity v is 20 meter per second, which is given in the question, and acceleration due to gravity is 10 meter per second square. So using the equation v equal to u plus at, we find out the time. So v equal to u plus at, modifying it in terms of t, we have t is equal to v minus u upon a. So final velocity v is nothing but 20, initial velocity u is 0, and acceleration is nothing but acceleration due to gravity, that is equal to 10. So after calculation, we find it 20 minus 0 is 20, divided by 10 is, time taken is 2 seconds. Now to find the height of the building, we will be using the equation h equal to ut plus half gt square. So we have h is equal to ut plus half gt square. Now again, as the initial velocity was 0, whole thing of ut becomes 0. Then we have half, acceleration due to gravity is given to be equal to 10, and time taken we have already calculated is 2 seconds. So we square it. So now we have h equal to 10 multiplied by 2 square is 4 upon 2, which is equal to 20 meter. So height of the tower is 20 meters, which is the answer. Now question number 13 says, a ball is thrown vertically upwards. It returns 6 seconds later. Calculate the greatest height reached by the ball and the initial velocity of the ball. Take acceleration due to gravity equal to 10 meter per second square. So we write the given things first. After writing the given things, we have to understand that the total time taken is 6 seconds. The scenario is a ball is thrown vertically upwards and it returns in 6 seconds. So that means the time will be divided by 2. So that first half is the time taken by the ball to go up, reach the maximum height, and then the second part of the time, then that is the second half of the time, is taken by the ball to reach back from the highest point to the ground. So let h be the maximum height reached. So time taken to reach the maximum height will be 6 by 2, that is 3 seconds. Now the initial velocity when the body was thrown up is 0. So the initial velocity u is equal to 0. We will be using the equation h equal to ut plus half gt square, which is the modified form of the equation s equal to ut plus half at square. So we put the values, and since the initial velocity is 0, so this whole term becomes 0. So we will be left with half gt square. So here we have half 10 multiplied by 3 square, that is half 10 into 9. 10 into 9 is 90, divided by 2 will be 45 and meters. So this is the height that the ball will reach. So to find the initial velocity, we assume that let u be the initial velocity, and since the ball will reach the maximum height and stop there for a very small moment, so final velocity v will be equal to 0. Now we will be using the equation v equal to u plus at. Now here a will be modified as g, that is the acceleration due to gravity, and since the body or the ball is in upward motion, that is going against the gravity, so it will be minus g. So here we have written v equal to u minus gt. Minus g means the ball is going upwards, that is against gravity. So we have to calculate the initial velocity u. So we construct the equation in terms of u. So taking everything on the other side, we have u equal to v plus gt. Now as the final velocity v is 0, so we have u equal to gt. G is 10, time is 3 seconds. So u, or the initial velocity, is 30 meter per second, which is the answer. Question number 14 says, a pebble is thrown vertically upwards with a speed of 20 meter per second. How high will it be after 2 seconds? Acceleration due to gravity to be taken, g equal to 10 meter per second square. So these are the things given to us. So here initial velocity u will be 20 meter per second, time is given as 2 seconds, and acceleration due to gravity g is 10 meter per second. So we write the given things. So we have to find the height h. We know that maximum height h is given as half gt square. So we just put the values and we find it to be equal to half. Acceleration due to gravity is to be taken as 10 as given in the question, and time is 2 seconds. So when we square it, it becomes 4 seconds. After calculating, we find that height is 20 meters, which is the answer. Now question number 15 says, how long will a stone take to fall to the ground from the top of a building 80 meter high, and what will be the velocity of the stone on reaching the ground? So first of all, we have to find the time, and then we have to find the final velocity of the stone on reaching the ground. So we write the given things. Now we have written the given things, and we know that h is equal to ut plus half gt square. Now since the initial velocity is 0, so we can directly write the same equation that we use for maximum height, that is h is equal to half gt square. So putting the values, we have height of the building is 80 meters, ut, the entire terms becomes 0, half, acceleration due to gravity is 10 multiplied by t square. Now solving this equation, we can find out the time. So we have calculated the time to be equal to t square is 16 seconds, so t will be 4 seconds. So the time that it takes to reach from the maximum height to the ground is 4 seconds. So first part of the question is solved. Now the second part of the question is to find the final velocity. For that we will be using the equation v equal to u plus gt. Now initial velocity u is 0, so we write it as 0 plus acceleration due to gravity is 10 multiplied by the time that we have calculated is 4 seconds. So the final velocity is 10 into 4, 40 meter per second, which is the answer for the second part. Question number 18 says, a stone is dropped freely from the top of a tower and it reaches the ground in 4 seconds. Take acceleration due to gravity g is equal to 10 meter per second square and calculate the height of the tower. So when they say that the stone is dropped freely, it means that it is falling under the action of gravity. So we write the given things. So the initial velocity u is 0, as when the stone was dropped from the building, initially it was at rest, and time given is 4 seconds. Acceleration due to gravity is 10 meter per second square. We have to find out the height of the tower. So we assume that let h be the height of the tower. So we will be using the equation h equal to ut plus half gt square, which is the modified form of s equal to ut plus half at square. Now when we use this equation, as the initial velocity u is 0, this whole term becomes 0. So instead of this, we could have just written h equal to half gt square. That is the equation for the maximum height. Now putting the values, we have h equal to since u is 0, so 0 multiplied by t is 0, plus half, g is 10 and time taken is 4, so square it. Now solving this, we find that h is equal to 160 upon 2. So when we divide it, we find it to be equal to 80 meters. Unit is very important. This is the answer. Question number 19 says, a pebble is dropped freely in a well from its top. It takes 20 seconds for the pebble to reach the water surface in the well. Taking g equal to 10 meter per second square and speed of sound 330 meter per second, that is the speed of sound in air, find the depth of the water surface and the time when echo is heard after the pebble is dropped. So we write the given things first. So we have written the given things. Time t equal to 20 seconds. Initial velocity u is equal to 0 as the pebble is starting from rest, and acceleration due to gravity g is 10 meter per second square. So the distance traveled by the pebble is going to be the depth of the well. So we will take it to be equal to d. So instead of the height, since we have to find the depth, we are writing d. So we assume that d is the depth of the well. D is equal to ut plus half gt square. Now since the initial velocity u is 0, this entire term becomes 0 and we have d equal to half gt square, and we put the values. So when we put the values, we find it that d is equal to 4000 by 2, which is nothing but 2000 meters. So the depth of the well is 2000 meters. Now we find out the time after which the echo is heard. Now it's given that the speed of sound in air is 330 meter per second. Depth of the well we have calculated to be equal to 2000 meters. So now the time taken to hear the echo after the pebble reaches the water surface. So once it reaches the water surface, we know that time is given as distance upon speed. So here the distance is the depth of the well and speed is the speed of the sound in air. So depth we have calculated to be equal to 2000 and speed of the sound is given to us as 330 meter per second. So after calculation, approximately you will get it as 6.1 seconds. This is the approx value. So now this time is the time after the pebble has already reached the water surface. Now we have to add the time that the pebble takes to reach the water surface, and that is given in the question as 20 seconds. So we will add that 20 seconds to this 6.1 seconds. So the time taken for the pebble to reach the water surface, it's given in the question, that is 20 seconds. So the total time that will be taken to hear the echo after the pebble is dropped is nothing but 20 seconds, that is the time taken by the pebble to reach the water surface, plus the 6.1 seconds, that is the time taken by the echo to reach us, that we have calculated here. So this comes out to be equal to 26.1 seconds. That is the answer. Now in this AV we have solved at least one of each type of the numerical. The few questions or the numericals which is left can be solved based on the same processes. Thank you.